Addition! So whether you're using the concrete, the pictorial, or the abstract method, our steps to success for using addition stays the same. Step 1, I can recognize different place values. Step 2, I can partition numbers into the correct place value. Step 3, I can add the smallest place value first. And step 4, I can recognize that a number exceeding the place value can be carried over. Step 1. I can recognize different place values. So here we've got an addition problem, 232.7 add 46.31. Now, it's very important before you do this step that you understand and recognize all the different place values that you might have using numbers. Now, if you're not sure how to do that, you either need to get yourself a place value mat, like I'm going to show you in a moment, or there's a link in the description below for the video for my video on understanding and recognizing place value. So either get yourself a place value mat or feel free to go and watch that video first and come back to this one once you've done that. Okay? Right, so you made your decision. So let's start off by using a place value mat because we're using the concrete method. Okay, so you might have a place value mat in front of you like this. If not, then feel free to draw your own onto a whiteboard like I've done here. Okay, so the reason why my place value grid only looks like this is because if we look at our numbers here, you can see why. We've got a tenth here, we've got a decimal point, we've got 2 ones, 3 tens, and 2 hundreds. Alright, we don't have any thousands or 10,000s or hundreds, thousands, and so on. Alright, so my place value grid, we're only focusing on the hundreds, the tens, the ones, the decimal point, the tenths, and because this number here has hundredths, we're focusing on the hundredths. Alright, your place value grid or place value mat might have more place values than this, and that's absolutely fine. But just looking at our question here, we can see that we're only going to be using this section of the place value mat. Step 2, I can partition numbers into the correct place value. So let's take this first number here, which was 232.7. Now we're going to use counters because this is the concrete method. You can use counters or any other manipulatives or concrete objects that you have in your classroom that your teacher said that you're going to use. In my case, here you can see I've used counters. And here we've used these black counters here to represent the tenths. So we've got 1, 2, 3, 4, 5, 6, 7 there to represent 7 tenths. Here we've got 2 ones, 3 tens, and 2 hundreds. Right, now what we're going to do is we're going to do the exact same for this number here, 46.31, and we're going to do it down here underneath. So let's start with the smallest place value. So here we've got 100th. So let's move this 100th over here into that column there. So we've got 100th. Next, you can see we've got 3 tenths. So we're going to need 3 counters in here. And voila! 3 counters in here. So we've got 3 tenths there. We need a decimal point in this one. So let's just put a decimal point in there. Alright. Next one, we've got 6 ones. So we're going to need 6 of these counters. Ta-da! Okay, 6 counters there, so we've got 6 ones. And then finally we need 4 tens. Abracadabra! Right, so we've got 4 tens, 4 counters there. We have no hundreds, so we're going to leave that column empty. Right, so we've done step 2. We've partitioned the numbers into the correct place value. Step 3! I can add the smallest place value first. So on our place value mat, we can see that the smallest place value we have is the hundredths. So that's where we're going to add first. And the great thing is, using the concrete method, we've got everything laid out already, so we just need to count them together. The first thing we're going to do is let's draw a line under here to represent where our answer is going to be. And we're going to add all these counters together first. So let's add the hundredth first. So we've got 100th. Right, let's move to the next column. We'll add the tenths. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, we've got 10 tenths. Now, 10 tenths actually makes 1 whole. So actually what we need to do is, and if you're using counters this is really easy, all we need to do is to stack all the tenths up into one nice pile. Whoa, just like that. So I've stacked all my tenths into one nice pile to represent a whole 1. Our next step is step 4. I can recognize that a number exceeding the place value can be carried over. So what that means is, here we had 10 tenths, which actually equal 1 whole number. Alright, if you count them all up, we had 10, so that carried over to the next column. So that's what we've done, we've carried over. So now that we've carried over to the next column, we can keep going. So we can count the next ones. So let's see how many ones we have. We've got 1, 2, 3, 4, 5, 6, 7, 8. Adding on this one that we've carried over, we have 9 counters there. So we've got 9 ones. Right, let's do for the same for the tens then, shall we? And find out how many we have. So, we have got 1 10, 2 10, 3 10s, 4, 5, 6, 7 10s. 7 10s. We've not reached 10 10s, so we don't have anything to carry over. So we're alright. Let's go on to the hundreds then, shall we? So we've got 100. And we've got 200s. Right then, let's actually write down what our final answer is then. So we know 232.7 add 46.31 will give us 200 and 7 10, so 279. Remember to add on the extra 1.01. And that was how we used the concrete method to add using column addition.